All right, welcome to video number 2. And this is all about triangles and the parts of some of these triangles. The first part we're going to look at is called the centroid. And a centroid is the point where the medians of a triangle meet. And in this case, point G is the centroid of triangle ABC. All right, and again, just picking up some notation, make sure you understand that and to write that when you're talking about the triangle ABC. Well, what's a median? Median is a line that goes from the vertex, and the vertex, of course, is one of these 3 points of the triangle, goes from the vertex of a triangle to the midpoint of the opposite side. And I've done all 3 of them here. AD is equal to DC. All right, AD, this segment from here to here, is equal to the segment from here to here, DC, which means that D is the midpoint. And therefore, BD is the median. And likewise, AF is equal to FB. And notice in this case, instead of one little tick mark, I've used 2 little tick marks to show that these 2 are equal, but these 2 are not equal. And AF is equal to FB, so F is the midpoint of AB, and that makes CF a median. And then lastly, BE is equal to EC. Again, 3 tick marks to indicate those 2 are equal. Makes E the midpoint of BC, segment BC, which means that AG is or AE is the median. And all 3 of those points meet at point G, all 3 of those lines meet at point G, and that makes G the centroid. Next relationship is the circumcenter. Circumcenter is the point where the perpendicular bisectors of a triangle meet. And in this case, point G is the circumcenter of triangle ABC. And I've drawn line M. I only went through one explanation this time. Line M is the perpendicular bisector of AB, segment AB. And notice how I write segment AB with a little segment above it. Since AD is equal to DB. Now, AD is equal to DB. Now, what this means is the measure of AD and the measure of DB. Their lengths are equal. I'm not saying that the segments are equal. I'm saying that their lengths are equal. And that, of course, makes D a midpoint. So this line M has bisected or cut this in half into 2 equal parts. And you can see I've put a little square here, here, and here, and that indicates that these are all perpendicular to these red sides, AB, BC, and CD. And the next relationship is the incenter. The incenter is the point where the angle bisectors of a triangle meet, and point D in this case is the incenter of triangle ABC. I have some more notation down here for you. Here, these 2 tick marks they're actually arcs, show that these 2 angles, angle CBD and angle ABD, are equal. Here I've got 2 tick marks and 2 tick marks, 3 tick marks and 3 tick marks. So these 2 are equal, but they're not equal to these. And AD, segment AD, bisects angle CAB, and that's how I write angle CAB. It's the exact same angle as angle BAC, and it is the bisector because the measure of angle BAD equals the measure of angle CAD. Here's BAD, and that's equal to CAD. And so since those angles are equal, that makes AD the angle bisector. And And finally, the orthocenter. The orthocenter is the point where the altitudes of a triangle meet. The altitudes of a triangle. And an altitude is a line that goes from the vertex of a triangle. Here's the vertex of the triangle, and it is perpendicular to the other side. And in this case, point G, therefore, is going to be the orthocenter of triangle ABC. Please make sure you fill out your whisk, and when you do, make sure that for the Q part that you have an answer. I'm not looking to see if you've understood. I'm looking for you to extend. If you have something that's confusing, please please mention that. If there's a question that you have, please mention that. But if there's not, then I need you to come up with a sample problem, or come up with a problem or a suggestion of something that may be confusing to somebody else or something. I need you to think more in depth about the material.